Alright, Assalamu alaikum everyone. Welcome to the course of AS Organic Chemistry. My name is Mariam Shaukat and I will be your instructor for this course. Now, let's talk about our lesson number 0, where we will be discussing or giving an introduction to organic generally and basically what hydrocarbons are. So, the first question is well, what are hydrocarbons? But even before that, why study organic chemistry? Organic chemistry is basically the study of carbon and its compounds. And the reason why we study organic is because this is basically perhaps, I think, the most easiest way to tell about its significance is that all of the synthetic drugs that you see around yourself, all of the dermatological products that you see around yourself, all of them have been formed with the help of chemists who understood organic chemistry. So, as you will go on after this A levels to your degrees, and if some of you end up doing a bio or chemistry major, you'll realize how important organic actually is in producing all of these products. And even naturally, organic exists in human beings, like if you were to study all the molecules that you are made up of and all the enzymes and everything, you'll come to realize that much of it has to do with organic chemistry. Some of the very essential products and molecules that we get from plants, extracts that we make from plants, they are dependent or are actually organic compounds. The chocolate you eat has an organic compound linked to it, the caffeine you intake. So basically, everything is more or less organic. And so this topic is like very important. Now, let me now kind of introduce what hydrocarbons are. I hope you're already aware of this since you have already done your O levels. Hydrocarbons are basically compounds of carbon and hydrogen only. Now, this only is very important, and many people in turn forget to keep this in mind. Hydrocarbons are compounds of carbon and hydrogen only. So, for example, alkanes, right? So, I hope you're already aware that alkanes have the formula CnH2n plus 2, but nonetheless, we will go over them when the time comes. For now, we're just giving an intro to organic. So, now, what I want to introduce to you at this point is what kind of classes of hydrocarbons will you be dealing with in this entire course. So, here are the three classes. We will be going over aliphatic hydrocarbons, alicyclic hydrocarbons, and aromatic hydrocarbons. Now, aromatic is more or less important for A2 organic chemistry, but we will basically touch upon it and get the gist of it slightly. Whereas aliphatic is the most important portion of AS organic chemistry, and we also require to know at least sufficient amount of information about alicyclic hydrocarbons. Now, without further ado, let's basically talk about each one of them and see what do we actually mean by these terms. So, aliphatic hydrocarbons are basically it's the fancy name for open chain hydrocarbons. So, let me give you an example. You see ethane right over here. You see how this is a linear molecule. It is open chain. This molecule is not enclosing upon itself or anything. It is basically open, right? So these are basically known as open chain hydrocarbons. Alicyclic, on the other hand, are cyclic hydrocarbons. If these hydrocarbons were to enclose upon each other and form these closed structures, then you can call them as cyclic hydrocarbons. And we will get to the details of this in a minute. Aromatic hydrocarbons are basically benzene and its derivatives, to put it very simply. What is benzene? That will come in a minute as well. But before that, let us now completely understand aliphatic hydrocarbons. I hope you are already now well aware of what open chain hydrocarbons means. Okay, now in aliphatic hydrocarbons, you get saturated hydrocarbons and unsaturated hydrocarbons. What do these terms basically mean? Saturated hydrocarbons basically means this hydrocarbon has the maximum number of hydrogens that it possibly can bear. Whereas unsaturated means that this does not have the maximum number of hydrogens. Let me give you an example that you're already aware of. So, alkanes, all of them have CC single bonds. And so, each carbon has at most three or at least two hydrogens attached, just like in this case over here. Every carbon in this case is there's a CC single bond, and therefore every carbon has at most three hydrogens attached. And if there was another C in the middle, you would have noted that it would only have two hydrogens. But the point is that we have CC single bonds, and so we get the maximum number of hydrogens that that organic molecule can have. However, in alkenes, we have to eliminate these two hydrogens in order to form a CC double bond in the middle. In this case, you can see that in order to get rid of these hydrogens and in order to form this double bond, our number of hydrogens in the molecule have been reduced. This is what happens in unsaturated hydrocarbons. You do not have that maximum number of hydrogens that that molecule can bear. So alkenes have CC double bonds, alkynes have CC triple bonds, and both of these are very good examples of unsaturated hydrocarbons. Alright, I hope that you now have a general idea of what aliphatic hydrocarbons are. Let us now move on. So talking about alicyclic are basically, if I were to take, let's say, pentane. So let us take, for example, pentane right over here. Now, if this pentane, for some reason, decides in order to get rid of this hydrogen and this hydrogen, what it can do is that this carbon can basically form a bond with this carbon, enclosing upon itself and forming a cyclical structure, something of this sort. Right? But obviously, in order for this carbon to form a bond with this carbon, they need to get rid of at least one hydrogen so that they do not end up exceeding their octet. And therefore, whenever a molecule, organic molecule, any, you can say even aliphatic organic molecule, closes upon itself in this way, we call it that now it belongs with the alicyclic hydrocarbons, alright? And you can now call it, before its proper name, you can actually write the term cyclo. So for example, this was pentane. When pentane encloses upon itself, you can see that it is forming some sort of like a triangle. And every end of this triangle, or every corner I should say, is representing a carbon. And because all of these are single bonds, I know that this will be an alkane. So this has been made right over here. And you can see that the name remains propane, but before that we add the term cyclo. Similarly, if you were to look at cyclobutane, you can see there are four corners, so there are four hydrogens. All are single bonds, so we know it's an alkane, and because there are four carbons, it will be butane. But it is not just butane, it is cyclobutane because this molecule encloses upon itself. Similarly, this is cyclopentane and this is cyclohexane. One important thing to note over here is that we can get alicyclic structures only when the structure has at least three carbons, because there is no possible way for two carbons to actually enclose upon themselves. I mean, just think about it for a minute logically. If I remove this and I remove this, how are these two carbons supposed to link with one another? If you end up removing these two hydrogens, and even if this carbon links with this one, all you get is an alkene and not an alicyclic structure. So the important thing to remember is that we start getting our alicyclic structures when at least there are three carbons in that given organic molecule. So I hope this is clear to you as well. Lastly, let's come to benzene. So benzene is a structure which looks something like this. If you basically want, you can forget about these double bonds for now and imagine this as cyclohexane. This is something you're already familiar with, as you can see over here. Right? This is something we did just now. So you can think of this as cyclohexane but with a bit of unsaturation. Actually, a lot of unsaturation. It has three bonds or double bonds basically inside of it. Okay, and sometimes we actually represent this as a circle in the middle rather than these double bonds, because in this case, if I were to number every carbon, you can see that the first carbon is forming a double bond with the sixth carbon, the second is forming one with the third, and the fourth is forming one with the fifth carbon. So because all carbons are involved in this double bond, we may basically just make a circle in the middle. Now this is a very simplified explanation. Obviously there is more to it than just that, but this is something that is up for discussion in A2 organic and not AS. For AS, just remember that you can draw benzene in either of these ways. Which one is favored over the other is a separate story, but for now just know this. The general formula, or I shouldn't say the general formula, but the molecular formula for benzene is C6H6. And if I were to draw its structural or actually displayed formula, it will look something like this. You can see there are 6 carbons involved. We have three double bonds, And because obviously, in order to satisfy the octet of each carbon, because it needs to form four bonds, I have attached one hydrogen each. So this is that expanded look or the detailed look of what is actually happening in benzene. So this benzene right here is it belongs to the aromatic hydrocarbons. And if you take this benzene and you make something else from it, so let me give you an example. Obviously, you don't need to know this, but if you end up making something like this, for example, from this benzene, then this is a derivative of benzene. And just for your information, I'll tell you that this thing right here is known as phenol. All right, and this will be one of the very important molecules that we will study in A2 organic. But the point to remember is that aromatic hydrocarbons are simply benzene or basically its derivatives. All of them belong to aromatic hydrocarbons. So now I hope that you already have a good idea of what we are about to study in this course. You know what hydrocarbons are, why study organic chemistry, what different type of classes of hydrocarbons we will be dealing with, and also have an idea of what aliphatic, alicyclic, and aromatic basically mean. And so when you have a molecule in front of you, you can easily judge which class of compounds or which class of basically hydrocarbons does that molecule belong to. So this is it for today. I hope you enjoyed the lesson. If you did, then give it a big thumbs up, subscribe to the channel, and hit the bell icon.